In this video, we will solve this problem right here, and so if you want, you can pause the video and attempt to solve. And so let's get started. So you have 200 grams of oxygen, and it is being stored in a container at 35 Celsius and 6 psig. We want to calculate the container volume in gallons. So we are assuming ideal gas behavior. So the ideal gas behavior formula is PV is equal to nRT. We want to solve for volume, so we want to solve for V. So V is equal to nRT divided by P. R could be 0.08206 LATM kmol. Additionally, 14.7 psi is equal to 1 atm. We will need to use this relationship in order to solve this problem. And so the first thing that we could do is get N. Get the number of moles of gas. So we have 200 grams of oxygen. So N is equal to 200 grams. So the molecular weight for plain oxygen, just O, is 16 grams per mole. But oxygen gas is diatomic, so it's times 2. So it is 32 grams per mole. This would allow us to cancel grams, so we would left off with moles. So we would get 6.25 moles. So we got N. And we know R, now we're going to get T. So we're given 35 Celsius, but in our formula for R, it wants it in Kelvin. So we need to convert Celsius to Kelvin. So temperature is equal to 35 Celsius plus, so if you want to convert from Celsius to Kelvin, you add 273.15. Now this would give us 308.15 Kelvin. So we know N, we know R, and we know T. Now we just need to get P. P is given as 6 psig. But the thing is, when you're dealing in the atmosphere by itself is 14.7 psia. And now you're adding the additional 6. So plus 6 psia. So we would get 20.7 psia. Because atmospheric pressure, in a typical day is 14.7. But now the container itself is 6. So you need to add those two together. But in this formula, it's LATM divided by K times mole. We have it in PSI. So we need to convert PSI into atmosphere. And we're given this relationship right here. That 14.7 PSI is equal to 1 atm. And this right here would give us 1.408 atm. So now we have everything, and now we will use this formula. So volume, which isn't going to be in liters, is going to be N, which is moles. We have 6.25 moles times R, which is 0.08206 LATM divided by K times mole times T. Temperature was 308.5 Kelvin divided by P, which is 1.408 atmosphere. And so if you notice, moles cancel here, so moles cancel, Kelvin cancel, ATM cancel, and we just have liters. And we would get 112.2 liters. But in our given problem statement, we want it in gallons. So converting from liters to gallon is a conversion I think we should all know. So we have 112.2 liters, and we know that 3.785 liter is 1 gallon. I'm guessing you learned this conversion in chemistry class. And if you didn't, now you know. And so this right here would give us 29.66 gallon. This right here is the final answer to our problem.